Okay, I started the recording.
Okay, so good afternoon, everyone. Welcome to the first of our lunch meetings of 2022. I'm happy that you could all join us. Um, I'm going to make a couple of announcements regarding upcoming um, chapter activities, and then I'll introduce our speaker. And following his presentation, I think we'll have time for some question and answer. So at that point, if you want to raise your hand, you can turn on your mic and you'll be able to ask your question. Next slide. All right, so a couple of announcements. We have some activities coming up in February. We have our math counts competition, which will be held virtually this year. Due to COVID, we will continue with a virtual format, and the hope is that next year we'll go back to an in-person math counts competition for all the chapters. Our annual Engineers Week Gala will be held on February 26th at the Airport DoubleTree Hilton. I don't know if anyone from the other chapters will be joining us, but we hope to see lots of folks from Miami. We'll also be having the third of our fourth annual wellness series lunch seminars. This one in March will focus on decision making. We held one in January. It was called Stress Less. We also have our March luncheon speaker, who was the FDOT District 6 Secretary, Ms. Stacy Miller, and that will be an in-person meeting, also to be held at the Airport DoubleTree Hilton. Next slide. And then we have rescheduled our mentor-mentee networking activity for March 31st, 2022 at SALT. For those of you that are unfamiliar, that's at the Rosten Teal campus on Rickenbacker Causeway. So I put the address there just to help everybody. Our fourth and final wellness series called Leading From Within is scheduled for May 11th. The wellness series are virtual. They're 30 minutes, so it's easy to participate at lunchtime if anybody has a chance. There's a sign up virtual flyer. I think if you search for it, you'll be able to find it and sign up for the rest of the series. And last but not least, we're excited to host our student golf tournament. This raises funds for student scholarships for high school and university students both. It will be held at Crandon Golf Course, and I believe the flyer will be out for this event sometime in the next week or two. Some of you might have already received it. I know Jeff went ahead and contacted folks at companies. I also forwarded the flyer to a couple of folks, but we'll have an official email blast from Tej in another week or two. And that's it for announcements. So let me introduce our speaker. We have with us today Mr. Shawn Waldeck. He's a senior program manager overseeing the C43 Reservoir design. And today he's going to give us an update on the project. He holds bachelor's and master's degrees in civil with an emphasis in structural engineering from the University of Rhode Island. He's a registered professional engineer in the states of Florida, Rhode Island, Connecticut, and Massachusetts, and brings over 30 years of experience in heavy civil engineering and construction management projects. During his career, he has designed and managed some of the most prominent and important Everglades restoration projects, for which he has received multiple FES recognitions, such as the 2015-2016 Project of the Century for the L8 Reservoir, and in 2006, 2007, received the Outstanding Technical Achievement Award for the EAA A1 Storage Reservoir. He was also awarded the 2013-2014 ASCE Palm Beach Branch Engineer of the Year Award. Mr. Waldeck currently serves as Senior Program Manager for the $640 million Caloosahatchee River C43 West Basin Storage Reservoir Design and Construction, which is located southwest of LaBelle in Hendry County. So, Shawn, thank you very much for joining us, and we'll let you take over and share screen.
Great, thanks for having me. Appreciate it. Inviting me here from. Oops, did I mess that up?
It's all good. We can see it, Shawn.
Okay. Okay, thanks for having me. I appreciate the invite for the joint technical session. I'm here in Palm Beach County today, but I'm usually stationed out on the site at the C43 Reservoir for construction. And can't see my screen. So are you guys seeing it, the advance of the screen?
I see the main screen right now, Shawn. Your title screen.
I can't see the screen because there's all these people from the lobby are waiting to be admitted. And so they're blocking the slide completely.
I
Like
can
Jose
see
Acosta's waiting.
I can see
Jose
this slide.
Matsusada is waiting. And several other people.
Maybe give it a second. Now I see your whole presentation, Shawn.
I still can't. I'm still seeing people waiting in the lobby to be admitted.
Can you see that now?
Yeah, I see it advance to the team.
Okay.
No, I still see the people waiting in the lobby to be admitted.
Can you accept that, or can you?
I've tried to do that. It just goes around in a circle. They don't get admitted. For example, I just clicked on Jose Acosta.
You can click close also.
Yes, but that closes him off and he keeps popping up. He just popped up again.
You may want to.
There, he's gone now. He might have
You
gone
want
off.
to resign in. Student.
Okay.
Okay, are we ready to move forward?
Yes, sir.
Okay, thank you. So the owner is the South Florida Water Management District. Joe Albers is the project manager. He has been for the last decade. He'll be retiring soon. Jim Orth will be the incoming PM for this project as it continues through construction. The construction manager is John Cresswell from the South Florida Water Management District. This project is cost shared with the Army Corps of Engineers, the Jacksonville District. The design team was Carollo, Stanley, and Terracon. And as we've moved into construction, JTEC, which is a joint venture between Jacobs and Tetra Tech, along with some of our key subs, including Nova Consultants there in Miami, Radis, helping us on our QA program, as well as Hiller's Electrical Engineering. And we'll be describing the contract packages for the program, which are 4 major contracts for Blue Goose, 2 for Harry Pepper on the pump stations, and the last contract, which is underway right now, is for the reservoir with Lane Salini. They're a joint venture or a consortium of Lane Construction along with Salini out of Italy. Quick overview of the project location. It's located west of Lake Okeechobee, about halfway between Lake Okeechobee and Fort Myers, just south of the Caloosahatchee River. As we zoom in on the project location, again, about halfway between the lake and the Caloosahatchee estuary, we have 500 acres footprint of a 2-cell reservoir planned, and it's under construction right now. Again, just south of the Caloosahatchee River. It takes water out of the Caloosahatchee River that discharges into or intakes into the reservoir. It captures basin flows out of the river, as well as Lake Okeechobee discharges, hopefully to diminish the amount of discharges that currently go out to the northern estuaries and south through the southern counties of Florida to help improve environmental conditions in the estuary. An interesting note that this reservoir is about half the size of the city of Boca Raton. It's almost 18 square miles in footprint. So it's very, very large contract. And the main reason that we're doing this project, it's a SERP project, number 1. So it's a Everglades Restoration Program project. And it's designed to improve the timing and distribution of flows into the Caloosahatchee estuary with attendant benefits throughout South Florida. it was originally designed under Accelerate, if y'all remember that, back in the early 2000s, when Accelerate program had 3 major reservoirs, the C43, the C44, and the EAA A1 reservoir. This component had 170,000 acre feet of storage, which is, if you had an acre of land, it would stretch 170,000 feet high into the sky. That's how much storage is captured in this reservoir. It takes in the wet season flows and discharges them during the dry season to maintain minimum flows and levels in the C43, which thereby improves the salinity barriers within the estuary, improving the ecosystem. As I mentioned, there were 4 major contracts that total about $630 to $650 million as of today. The total contract, or the total project budget, is about $1 billion, which includes land, engineering, and a host of other smaller contracts that were advanced in advance of the Package 4 reservoir contract. The reservoir, again, 10,000 acres or so, has more than a dozen water control structures, and most of them are pretty major, including the S470 reservoir pump station that we'll get into in a minute. That pump station is located right next to the Townsend Canal, which is the main conveyance feature south of the river, and that's designed to capture up to 1,500 cubic feet per second and discharge it into the reservoir. It'll take approximately 60 days at round-the-clock operation during the wet season in order to fill it. The idea is to fill it about once every year and drain it once every year during its operational cycle. Just to give you a quick heads up on the construction status, I know there's a lot of fine detail in here, but we're roughly 40% complete with the reservoir construction. Each of the colored lines represents a different feature, such as dam foundation preparation, soil bentonite wall construction, and perimeter canal construction and the like. So once we're completed, all of these smaller dash lines will be a solid color. Again, the 12 or so water control structures are shown on the graphic, and some of them have already started. And I know this is a blurry aerial. It's taken above the clouds, as you can see. That's how high you need to be in the sky in order to see the entire footprint of the reservoir. So it's about 6 miles wide from east to west and 3 miles high from north to south. And you can see that the reservoir is in various stages of construction in this photograph. And just tell you a little bit about some of the protected species that we've seen on the project. We've seen practically all the threatened and endangered species on the list for South Florida, including the panther, manatee, eastern indigo, gopher tortoise, and the like. In fact, we found one of the largest gopher tortoises recorded in South Florida on our project site, and she got relocated to a recipient site and is doing well. We have a family of panther on our site as well, so that's pretty exciting. The original design, as I mentioned, was completed during Accelerate, picked up back up in the Restoration Strategies program for the district in 2014, and due to updates in the dam safety criteria after Hurricane Katrina, the project went through a total redesign for the reservoir dam facility. We conducted IEPRs, which is the independent peer review, value engineering, and all of the core reviews necessary to pass scrutiny through the dam safety group. In consequence, dam breach and ops plan EAPs, which is emergency action plans, are currently in development. Let's talk a little bit about the project delivery plan, the 4 major contracts for the work. included what we call package 1, which was a preload and demo contract conducted 3 or 4 years ago now. That was primarily to preload all of the structure sites within the reservoir dam footprint to consolidate the clays, which I'll get into in a little bit in the presentation, but to consolidate the clays so we could minimize the amount of future settlement once constructed. These mounds were pretty large. They were 250,000 cubic yards each. They covered a footprint of almost 7 acres and were on the order of 50 feet high. And those mounds were, here's another picture just showing one of those mounds for one structure on site. Those mounds were left in place for about a year or so in order to take out, again, the settlement due to clay consolidation. And we monitored those settlements for each of those mounds. And on this graphic, you can quickly see that the fill height, which is the orange line, as the fill was being placed, the settlement of the ground surface was induced up to almost 30 inches of settlement at each one. So you can imagine a structure in the dam settling 30 inches. That probably wouldn't be too good. So we took out the settlement and we monitored the clay layer to make sure that we dissipated the pore water pressures, and that's what this graphic shows. Again, the fill placement through time, and then the representative piezometer readings. So as time went on, you can see the piezometer readings or the pore pressures dissipated, and that's what we're looking at during construction to make sure that the dam, as it's being built, settles as we predicted. Package 2, it was a small, relatively small 200 CFS pump station. Its purpose is to tie in the southern perimeter canal, which is the southern blue line on this reservoir picture, to reroute water supply that had originally gone through the reservoir to the east. And that was critical because we had to maintain that water supply to the farmers on our eastern neighbor border. This pump station, again, was built a couple of years ago, is in operation. These are just some photos. I like photos better than lots of words. So we had 3 vertical pumps at about 65 CFS each to give us close to the 200 CFS capacity. And you'll see a lot of our photos make use of a lot of drones. Everything's so big, the only way to really capture it is through a drone imagery. This is just an example of the pump tube. It's about, as you can see, about 5 feet in diameter. And this is a picture right from above as the concrete pump is pumping the concrete mix into the foundation for the pump station. And then we set the tubes. And then this is the finished product. So the canal in the foreground is the Townsend Canal. That canal extends all the way past the intake at 470, which is the primary intake structure, and continues south to agricultural interests on the southern border as well. In the interim, you can see the orange pipe in the background. That's a 6-foot diameter pipe that discharges into a temporary bypass canal so that we could maintain that water supply into the eastern properties. Package 3 delivery was the S470 pump station, and that's at the northwest corner of the reservoir. And again, that was to take water out of the Townsend Canal, the dark blue north-south line that connected to the river. And the intent was to discharge up and over the embankment. So the pump station's built under package 3, while the embankment portion is built under package 4. So there's a lot of coordination between those two. Eventually, when the dam gets completed in the vicinity of the pump station, we'll install the pipe, connect the pipes to the reservoir. There are 4 375 CFS pumps. It's electric motor driven and a total dynamic head of 42 feet. What's spectacular about this project is that each of those pumps is a 2,500 horsepower electric motor. So we'll get into what we had to do about that in a second. But during the design development, we looked at physical pump model tests to maximize the efficiency of those pumps. And the main reason is because the 2,500 horsepower or 10,000 horsepower total is a pretty hefty electric bill when we run it. So we wanted as efficient of a system as we could. So we did some extensive modeling to design the form suction intake and vortex breakers into the pump station. We also use CFD to develop the discharge, which you can see on the right, the S470 intake and the 483 discharge in a combined canal that eventually connects into the Townsend. We were able to determine from that analysis flow velocities to design our erosion protection, our riprap, as well as to make sure we had adequate capacity in the intake and discharge for the reservoir. I mentioned the electric power. We ended up having to have a dedicated substation built, which was about $5 million. I'll show you a picture of that in a second here, along with a lot of optimization on the intake system, as I noted, and evaluation of the Townsend Canal conveyance capacity resulted in some upgrades to that facility as well as part of the project. This is the Townsend Canal on the northern segment that connects to the river. So the C43 River is actually in the background in this photo, and the Townsend Canal runs south to our reservoir project. This canal had to be improved, as you can see in this picture, to make sure that we had adequate capacity within the facility. The substation that I mentioned, it was determined by FPL that if we had taken power off of the transmission corridor that runs north of the reservoir and directly into the pump station, we would have resulted in a brownout to the city of LaBelle. So we had to build our own substation in order to knock down the power to bring it to the pump station and minimize flicker with our neighboring communities. Some of the other challenges were on the geotechnical side. Because we had nearly 40 feet of head in the reservoir and then some, we had significant uplift pressures exerted on the foundation of the pump station. So that had to be designed in order to make sure that we didn't lift the pump station from its location. Getting into an early construction photo. This is an aerial of the base slab being poured. You can see the line of concrete trucks, CEMEX trucks, circling around the yard, and those were placed mostly during night. We found that our night pours on our major concrete pours were most effective for minimizing temperature problems with the concrete mix. Here's just a photo of some of the FSIs and the intake bays for the pump station, just to give you an idea of the scale. You can see the people below, just to give you a scale of the size of this facility. Again, each one of those 2,500 horsepower motors serviced a 7-foot diameter pump that discharged to you can see the left pipe within the pipe gallery, discharges to the downstream side of the reservoir, of the pump station, and then ultimately into the reservoir. This is what the downstream side of the pump station looks like. For now, we've installed a manifold. That's an 84-inch diameter manifold that will be removed once the dam is constructed, which won't be too far from the back side of this pump station. So you can kind of see we're already preparing our dam foundation to the lower left, and that's how close the dam will be to the pump station. Package 4 is the dam. That's the big one. That's the $500+ million contract, and that was let in 2019. And again, we're about 40% complete on the project. One of the things that I'll just share with you really quick is that clay layer we talked about. Of course, we got about 20 feet plus or minus of sand and weathered limestone from the surface down to the top of the clay. The clay is our gold dirt. So that's almost almost entirely uniform across the 10,000 acres, which makes it very very unique in that we can get 18 square miles of a clay liner not too far below the surface of the dam. So that's the good part of the clay, not the settlement part, right? So the cutoff wall that we'll show you ties into that clay layer, effectively making a seepage-free bathtub. This is just a quick cartoon cross-section of what that dam looks like. It's a 3-on-1 side slopes, an elevation of 54, with a ground surface average of about elevation 20. We've got a bentonite cutoff wall that ties into the existing clay layer, along with a backup chimney drain and toe ditch to capture any seepage that may penetrate or escape the cutoff wall. And then there's a perimeter canal on the outside perimeter that collects the flows, any flows that might enter into the seepage canal, as well as agricultural flows, and we'll show you in a minute also water supply deliveries as well. Total volume of earthwork is about 20 million cubic yards. We'll probably move closer to 30 million cubic yards. We expect to use almost 30 million gallons of diesel fuel to construct the project. And this is just a close-up cartoon of the internal features of the dam. Again, the water surface elevation's about 20 feet or so above the existing grade. And then we did some fancy CFD to evaluate some of our structures. This one happens to be the structure that divides the two cells, just to make sure that we're adequately protecting against erosion. When one reservoir cell is full and another is empty, we could have as much as 20 feet of head against that gate, and we needed to make sure that we protected the dam appropriately. For that one, and we'll go right into the foundation prep. So this was an old citrus grove, all 10,000 acres of it. And we had to remove all of the pipes, all the underground irrigation pipes within the citrus grove. And they were spaced every 50 feet or so. So we had to dig up every single one of the pipes before we could prepare the foundation, dig them up, and then backfill them to create a suitable dam foundation. This is a picture, an aerial picture of a completed foundation segment in the foreground. So after we've done our remediation, then we come in and proof roll, and we're ready to fly each segment. And once we're done flying each segment and doing our foundation mapping, we're ready to start building the dam. This picture just shows one particular segment that shows the placement of the drainage blanket on the downstream toe. So the white sand material is the drainage blanket that we're getting from Ortona, Florida, about 20 miles away. And then as you go up the view, that's the dam itself, or at least the dam footprint itself. And then in the very foreground is the perimeter canal constructed in segments. We also had to do a bunch of workarounds in order to capture. On the right-hand side is a drainage feature. We call it the Roberts Canal, that actually runs through the reservoir footprint, and that needed to be rerouted around the reservoir into a new perimeter canal in the foreground in order to bypass those flows. So we have water supply going through the reservoir, as well as drainage going through the reservoir that needed to be managed. We have a thing called a master layout, and I know you can't see what's in each one of those squares, but each one of those squares is a borrow location on this footprint. So each one is cataloged. There's a qualification associated with each one of those borrow locations, and that's the material that we use to build the various parts and pieces of the dam. zooming in on one 11 by 17 segment of our master layout kind of gives you an idea once you overlay the aerial view where the spoil piles are and what their designations are for the placement of the dam. So each one of these locations or each one of these piles is tracked. So we know where the material came and where it went in any particular segment of the dam. Quick look at the soil bentonite wall, probably the most important feature of the dam itself. It's designed obviously to prevent seepage through the dam. It's also the least or the lowest tech construction you'll see. So it's a very, very sloppy operation. We just have a trench with slurry and lots of mud. Once the trench is backfilled with a bentonite and mud mixture, most of that mud comes from the clay layer that we've keyed into below the footprint of the dam, and that becomes the basis of the cutoff wall. We actually build it in two pieces. So we built this piece shows the segment that goes from the grade all the way down to the tie-in, and then once we build the embankment on top of this, we build a phase 2 cutoff wall that ties into the first one. And this is maybe a little better perspective showing the blanket on the right as well as the cutoff wall activity on the left. And it's simply just mixing that mud with a bulldozer and pushing it back into the trench as they move. They were producing about 200 feet a day of cutoff wall. That's currently going on right now. We also have a lot of riprap. All of our channels are lined with riprap. And we also have a pressure relief system on that Townsend Canal side. We've got over 40 feet ahead. And the idea is to relieve the pressure under the confining layer, the clay layer, through sand relief columns that exit at the ground surface. This is a little graphic showing how that's supposed to go together. This is a picture of us just getting started with what we call proof of concept. So each one of those columns gets drilled to 60 feet deep and then filled with filter sand. There's a big pile of it in the background there to create that sand relief system. That's underway right now. And it's just another perspective looking in the other direction. They have to drive those casing and then they have to drill it out with the machine in the foreground. Again, mentioned we have some other major water control structures. This is called S475. It's the divide structure between the two cells. And that's just getting underway right now. And here's a couple of photos of some other water control structures along the perimeter, and you can see the dam construction going.
Shawn, you're muted.
Shawn, you're muted.
That better?
Yes, sir.
Yes.
Sorry about that. Must have pressed the wrong button. Anyways, this is another water control structure under construction.
We lost your screen too, I think, Shawn.
Is that better?
Yes, we can hear you and see you again.
You can see. And then this is a picture of the demo of the existing pump station at the western side of the reservoir. That was the original water supply to the farms to the east. Quality control and quality assurance is pretty heavy on this job, very robust. We have to do it within accordance with the Corps of Engineers requirements. We developed our own plan. We have our own validated quality assurance and quality control labs on site. And we have a very robust data management system to handle over what we anticipate to be over 100,000 test records required at the end of the project. So we call our data management system the dashboard. It's tied to the contractor's segment identification and nomenclature. It's integrated with inspection reports and Radis's quality management system, and it also houses all of the quality checklists in the system. Ultimately, the goal is to collect that and produce a concrete materials completion report in accordance with the Corps guidelines for documenting the construction of the structure. It's just a quick screenshot of what our dashboard looks like. So at any given location, we can identify where photos are taken or where daily reports are recorded. And this is very searchable. It can be reviewed by the project managers in West Palm Beach, as well as serves as a repository for all of the reporting. This just shows some additional capabilities to show you where all the tests are located at any given segment and their disposition, whether they passed or failed. And that continues for the entire footprint of the reservoir. And that's what I had for a presentation for today. So thank you very much.
All right, thank you very much, Shawn. I think we're gonna take questions from the audience now. I know there's at least one question so far from Laurie Swanson. I don't know if you can see the chat, Shawn, but her question is, well, actually she has two. So how long will it be before the discharges from Lake Okeechobee to the Caloosahatchee River stop?
Well, they'll never stop, but we're going to try to capture them before they reach the estuary. So we anticipate first fill sometime in 2025.
Okay. I guess I don't know if you can hear me, but
I can.
Pardon?
I can, yes.
Okay. I guess we've seen going down the Caloosahatchee River, it's affecting we're getting those blue-green algal blooms, and
Sure.
it corresponds to every time that they discharge water from the Caloosahatchee or from the Lake Okeechobee. So
Sure.
I guess my question is, how does this project going to stop that from happening?
So the idea is a great question, and we only have so much time to present, but the idea is also to include a water quality component that we're working on right now, and that's to treat the water in the reservoir. So we should be able to significantly reduce the nutrient discharges west of where the reservoir location is by treating it in the reservoir itself before we discharge back into the river. So it should have a significant effect of reducing those algal blooms as you move west of the reservoir. We're also working on some pilot water quality projects further east towards the discharge at the lake location to come up with some additional water quality treatment that will also serve to improve water quality moving west from the lake.
And when will those water quality aspects be completed? You're saying the reservoir itself will be complete in 2025, but the water quality additional, when will that be?
That's still in the planning phase, so if I could guess, but it's probably nothing better than a guess. So we're still doing some evaluations on the types of treatment systems. We're looking at wetland treatment systems and others, even some alum treatment as well. So hopefully those will be online, somewhere near when the reservoir is complete by the time it goes through the planning and design and construction process.
Okay, so, I mean, we're seeing this every time there's this, where they open the floodgates or they release the water from Lake Okeechobee. So once this reservoir is in place, is that going to be significantly reduced as far as the direct discharges from Lake Okeechobee?
It's this is a part of the puzzle. So the reservoir doesn't treat all the average annual basin discharges out of C43 basin, the Caloosahatchee Basin, which includes lake discharges. It treats about 20% on average, but we expect that to make some measurable improvements in the water quality going into the estuary.
Okay, because I mean, I lived over on the west coast of Florida and continue to be over there frequently. And I've, I guess, utilized the Caloosahatchee River for decades for, for recreational purposes. And I can only tell you that it's, these discharges from the lake are completely destroying the ability of the river to be used for recreational purposes, And I think our hope has always been that this project would actually, alleviate that problem, because every year now we're not able to use the river during the summer, during the summer months when the discharges are occurring. And it's also impacting, the discharge to the Gulf of Mexico is affecting the water quality at all the beaches as well. And so it's having a very major negative effect, on the west coast of Florida.
Sure. Yeah, I've worked on the project siting since 2002 for the C43, and the original purpose was to restore the estuary. So everything kind of east of the reservoir location is the lake water. So that's why the South Florida Water Management District, in recent years has started taking a much harder look at treating, those flows coming out of the lake before it gets to the reservoir.
Okay, so you're saying that this is only going to help by 20%? Is that what you're saying?
It captures 20% of the average annual discharges. So
okay.
It's a significant amount of water, but if we had more land and a bigger budget, we probably could use a few more reservoirs.
Okay, so can you just then describe for me how the reservoir is supposed to work, as far as, generally when is the water captured and how is it discharged? And you mentioned the canals that, I guess provide water for the farmers and so forth. Can you just kind of give us an overview, a general understanding of how that's supposed to work?
Sure. It's really just a big storage tank, equalization tank. So it's designed to pump water in during the wet season until it's full. And the water would be pumped in through that side canal. We call it the Townsend Canal, which is also a agricultural system that extends way further south of the reservoir. And we will capture those Lake Okeechobee discharges and basin runoff during the summer and store them until probably mid-dry season and start discharging when it's a lot drier and the flows across into the estuary are much lower. And then we'll discharge back into that perimeter canal we're building right now. And that will be directed back into the Townsend Canal and head north back into the river. So when we're pumping, we're not discharging, and when we're discharging, we're not pumping.
Okay.
All right.
And
let me jump here and ask. Does anybody else have any questions? We want to give others a chance to ask questions. So, are there any other questions? Anyone else in the audience?
What was that system you were using, Shawn? This is Denise Palmetier with Kimley Horn, that you're tracking the reports at the very end there that you were showing?
Sure. That'll be a subject of another presentation, hopefully soon. That's our C43 dashboard. So that's integrated with our dam safety data collection system. And it's a proprietary system that JTech developed to capture that data. It's integrated with Radis's what they call a quality management system, which organizes all of the tests and the test data. It's integrated with that so that we can see in a visual format, in a GIS kind of format, all of the reports, all of the test results, and all of the photos.
Yeah, it's very impressive and interesting. I look forward to seeing that in a presentation too. Now, are y'all just using it on C43? Is the district going to be incorporating that on other projects too?
Yeah. So we're already working with the district to incorporate it into C44.
Okay.
And we're the Corps of Engineers is working with us to see how they can integrate it for EAA as well.
Okay, thanks.
Sure. Thanks for the question.
Mhm.
Do we have another question?
I would like to follow up with on the when you're capturing the discharges from Lake Okeechobee, are you anticipating then that you're capturing 100% of those wet season water table discharges from the lake, or how much of the discharge from the lake are you capturing into the reservoir?
That's hard to say because it varies year by year. So on an annual basis, the C43 River Basin is about 85,000 acres or so. All of the runoff, so all those other side ditches and creeks and canals that tie into the C43, plus whatever Lake Okeechobee discharges at any given time during the year, constitute what's called the basin flows. So those can be on the order of, say, 1 million acre feet every year. Actually, it's a little bit more. The reservoir captures 170,000 acre feet of all that water. It doesn't make a distinction between what runs off the basin, every time it rains hard, and the lake. It just captures what's in the basin.
Okay, I guess it seems to me that we see this algal bloom when they discharge from the lake. That seems to be when we see the biggest problem coming down the Caloosahatchee.
Sure.
So I guess, is there any way, what's the volume of the water that's being discharged from Lake Okeechobee? And what is that?
Again, that's highly variable depending on the time of year, how full the lake is, and how the Corps operates their discharge. So off the top of my head, I don't know how much volume that is. It
During the wet season, in other words, because that's when I guess I think they started discharging in October last year, and
Sure.
and then shortly thereafter, the river couldn't be used for any kind of recreational purposes after that.
Sure.
You know, there's no
Yep.
swimming, no anything in the river. So it's I guess what I'm hearing is you think this project will help with that, but we don't really know for sure how much it's going to affect it.
Well, we know that we're going to improve the quality of water discharged west.
But to what to a measurable amount, we don't know. We don't know to what degree that will be improved. Is that correct?
Yeah, I mean, I think we have confidence that it will make a significant improvement. Whether additional features need to be added, that's the study, further east to help further improve the conditions west of the reservoir. That's sort of to be determined, but it's the district and the Corps of Engineers use adaptive management to kind of manage how we use the reservoir and those other quality features to maximize the benefits to the west.
Shawn, I have another question too.
Sure. We have
This
other
is-
questions from Shawn.
Okay, go ahead.
I see Denise and Vijay. I would like to give Vijay
Go ahead.
had hand raise. Now you don't have it. Okay. Denise, do you have a
Okay,
question?
thanks. Yeah, so on the S470 pump station,
Yes.
you guys are going to be able to go ahead and start that up. When is that one anticipated to be complete? And when will you be doing the testing for that startup?
Great question. So 470 is almost done. We're about 95% complete. We're making the final electrical connections to that big substation that I showed you.
Okay,
And we'll be able to, using that manifold I talked about in the picture there, we
Right.
can recirculate the flows to start up the pump station probably late spring, early summer.
awesome. Thank you.
Okay. I see VJ, I don't know, I see VJ's hand raised. I don't know if that's true or not.
Yeah, yes, Swan. So quick question for you, Shawn.
Maybe.
You have been working on this for more than a decade now. So far, what would you say have been one of the biggest challenges managing one of the biggest job in West Coast of Florida?
Well, there's a lot of them, and it depends on what year of working on it, right? So right now, the challenge is just the coordination that's required on a project of this magnitude with all the stakeholders. So we had the young lady who obviously is very interested in the success of this project on the call. We have the public, we have the landowners, we have the farmers, we have the coordination with the regulatory agencies and the Corps of Engineers, and we have water. So when we're building a dirt work job for 5 years, it rains 50,000 acre feet every year. As soon as we're done with the cutoff wall, I've got 50,000 acre feet of water to deal with, to discharge or to manage. So it's just a combination of all those things, and of course the construction time frame is very, very short. So everybody's working really, really hard to get this thing done.
Shawn, one of the most interesting parts of this project has to do with the research and development of new ideas, innovation. You have had to do a number of pilot projects to test certain ideas.
Sure.
From very early on. Remember the test cells.
Yep.
And I guess as a result, there was this redesign that you indicated in 2018, or kind of a design update.
Sure.
Is there, can you give us kind of a very broad summary of what the redesign was, and as a result of what type of research and development projects?
Sure. Well, as you mentioned, in Accelerate in the early 2000s, the district undertook a series of pilot projects. Test cells were built for each of the reservoirs. So it was set up so we could evaluate constructability, and we use the materials that we have on site. What were the effects on water quality in some instances? How are we going to protect the dam faces and surfaces? All of those things were studied during the development in Accelerate. Carrying through after 2005, we had Hurricane Katrina, which greatly resulted in a revision to the Corps of Engineers dam safety criteria. So when the project was picked back up in the mid 2010s, the engineer had to redesign to meet all of those criteria. And then moving into construction, we have things what we call proofs of concept. So it's one thing if you're working on a 10-acre Walmart parking lot. It's another thing if you're working on 22 miles of dam where you're trying to make as efficient and productive decisions as you can, still delivering the quality to meet those dam safety guidelines was critical to, or is going to be critical to success. So, things like figuring out how the cutoff wall should work, things how the soil or the sand relief column should work, and how do we do our dam foundation preparation, and how do we build our dam if we're doing 22 miles of it? How's the most efficient and quality way to build this facility? So it's an ongoing effort even now.
I have one last question from the chat from a Rex Robinson. He's asking, will the district or the U.S. Army Corps be maintaining and operating the reservoir after completion?
Yes, great question. So the South Florida Water Management District will be charged with with the dam safety program for managing and operating all of the reservoirs. The Corps of Engineers built C44. South Florida Water Management District is the contracting authority for C43, and the Corps of Engineers will be the contracting authority for EAA. But at the end, the South Florida Water Management District will own, operate, and maintain all of those facilities.
I think we have time for one last question, maybe one or two.
Sure.
Does anybody else have a question?
Yes,
Anything-
I have
Any-
one more.
too. Yeah,
I-
yeah.
I read that there was a project that was supposed to discharge water from the lake to the Everglades to flow south to sort of rehydrate the Everglades. Are you part of that, or is that a separate project, or what is the
that is-
status of that project?
Yeah, that's another great question. So that, yes, because I've been involved on all of the district's major reservoir projects, back in Accelerate, that was the EAAA1 reservoir. It since got converted to a flow equalization basin to help modulate flows into the existing STAs. The district is currently building the A2 STA, which is the EAA is south of Lake Okeechobee, and it's designed to capture those southern discharges in the, from the lake and in the basins into a reservoir that the Corps of Engineers is currently designing and will ultimately build, and discharge it through a new STA. So yes, there is a project south of the lake.
And do you anticipate that that will also help with the situation with the water flowing to the west? If there's another way to, in other
Sure.
words, if some of the water is being discharged to the south, that will help to alleviate some of our problem with the water quality to the west, or not?
Absolutely. So
Okay.
the two reservoirs on either coast for each, the Caloosahatchee River and the St. Lucie River, capture those flows that move east and west. And then the reservoir in the south will capture an even greater volume of water for ultimate treatment through STA. So that should help alleviate those higher levels of discharge east and west as well.
I think there was one last question from someone else. I think they had a question. All right. Well, if there are no more questions, I'd like to thank Shawn very much for joining us for our January membership meeting and technical presentation. And I hope some of you will be able to join us for our upcoming events.
Thank you for having me.
All right. Thank you.